Reflections, when we are dealing with reflections, one, of course, for reflection, we have what we call, it's the same thing like how we deal with reflections. Let's say if it is in mirrors, we know it that for reflection, the image distance is the same as the object distance. So we should also have that one in mind when dealing with reflections in mathematics. So under a reflection, a point and its image are equidistant from the mirror line, or from what we call the line of reflection. That is, the object distance from the line of reflection, or what we call the mirror line, should be the same as the image distance from the mirror line. Then the mirror line also is a perpendicular bisector to the line joining the point and its image. The mirror line is always a perpendicular bisector to the point joining to the line, the perpendicular bisector of the line joining a point to its image, meaning that if you have, let's say, an object here, maybe, and then its image is here, this is the object O, and this is the image O prime. Then this is the mirror line, and then this is the line joining the object and the mirror line and the image. So the mirror line, this one, is a perpendicular bisector, meaning that it cuts this line, OO prime at an angle of 90, and it also cuts it through the center, because that is what basically a perpendicular bisector does. It passes through the center and then it cuts the line at an angle of 90 degrees. Then points on the mirror line are invariant, and then the object and the image are indirectly congruent. Okay, let's look at this basically in an example. We have triangle PQR is such that P has coordinates -2, 1, Q with coordinates -3, 3, and R with coordinates 2, 2, the vertices. Find the coordinates of the image under reflection in the line X equals 2. Find the coordinates of its image under reflection in the line X equals 2. So we are going to use the graphical way to show this. And in the graphical way, first of all, we shall first plot this triangle PQR on a graph paper. So you can see the triangle PQR is here, PQR is here. This is triangle PQR on the graph paper. Then after we draw the line of reflection, or what we call the mirror, which is the line X equals 2. This is the line X equals 2. This one here. So after drawing the line, which is the reflection line, X equals 2, we now start reflecting each of those points. So remember, when reflecting through the mirror, we draw perpendicular lines to the mirror from the object. From the object, we draw perpendicular lines which are meeting the mirror. So meaning that if we start with point Q, we shall draw a line which is perpendicular. Since we are dealing with a graph paper, this line is even there. So we just need to stress it with our pens or pencils. This line must meet the mirror at an angle of 90, and we make it go through or extend further ways the other side of the mirror. Because we are reflecting, if the object is this side, we expect the image to be on this other side. So after drawing this line, you then measure the distance from the mirror line to the object. So measure this distance from the mirror line to the object. So if this distance, let's say if it is 2 meters, or in this case, if you have to count squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then we should also count an equal number of squares for us to form the image, but behind the mirror. So meaning that even to find our image, we count 10 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So where the 10 squares stop, that is where the image will be. So we do so because in dealing with reflections, the image distance from the mirror should be equal to the object distance from the mirror. So next we can go to point R. So since point R is exactly at the mirror surface, for it, when it is reflected, since it is at a distance of 0 from the mirror, its image will also be at the same point, which is at a distance of 0 from the mirror. So we can also draw another perpendicular line which meets the mirror from point P, and then we look for its image. So this perpendicular should meet the mirror at an angle of 90. Then measure the distance from P to the mirror, and then measure the same distance on the other side. Where it stops, that's where the image of P, call it P prime, will be. Then afterwards, you can join the points P prime, Q prime, and R prime to form the image of PQR, which is a reflection of P, which is a reflection of triangle PQR in the line x equals 2. So basically, this is how we deal with reflections through mirror surfaces, or sometimes through what we call lines. Sometimes we shall also be given equations of line to act as our mirror surfaces.